Hi, and welcome to another edition of the Women in 3D Printing Youth Webinar Series. Women in 3D Printing is a global organization dedicated to promoting, supporting, and inspiring women who are using additive manufacturing technologies. Our mission is to increase the visibility of women in the additive manufacturing industry and encourage more women to use 3D printing technologies. My name is Sanjana Narayanan, and I will be your host. I am a junior at Mission San Jose High School in Fremont, California, and the Youth Ambassador for Women in 3D Printing. I aspire to bring awareness about the various uses of additive manufacturing to students using the webinar series. The Youth Webinar Series is sponsored by XT Innovation, a Defo Systems partner. XT Innovation focuses on cloud, software, consulting, and value-added services for product development technologies enabling 3D design, engineering, simulation, data management, process management, quality, and compliance. Our guest today is Carolyn Kincade. Carolyn completed her dental technology diploma from NATE in 2007 and worked in privately owned dental laboratories where she focused on dental device construction with a high need for aesthetics. Carolyn joined IRSM in 2013 and is interested in using digital technology to replace conventional dental processes. She went on to further her post-secondary education and obtain a Bachelor of Technology in Technology Management in 2017. She uses conventional training, an interest in digital technology, and aesthetic skills to help patients needing intraoral prosthetic at IRSM. Carolyn is very involved with the College of Dental Technologists of Alberta, sitting on two committees, the Finance Committee and the Competency Subcommittee. She was also a member and chair of the NATE Dental Technology Advisory Committee from 2007 to 2017. She's now a board member for the Bachelor of Technology Advisory Committee and the Alumni Association Advisory Committee at NATE. Hi, Carolyn. Thank you so much for joining us today.
Hi, thanks for having me.
Before we dive in, can you start by sharing your journey into 3D printing, and was there anything specific that got you interested in the field?
I would say it really goes back to when I was at NATE. When we were in our final year, additive manufacturing was kind of like this maybe in somebody's lifetime, but certainly not in your lifetime. It's not something that you're going to see. And we went on a tour of IRSM when I was a student, and it was just completely inspiring to see all of the work that they were doing for head and neck cancer patients. And it really, lit this fire under me to do everything within my power to get there. Luckily enough, I was successful in that, and I joined IRSM in 2013.
Thanks. And can you talk a little more about like the specific field of additive manufacturing that you work in?
So at IRSM, it would be classified as medical dental. We are a multidisciplinary team who uses all sorts of resources to help rehabilitate head and neck cancer patients and also trauma patients. So we're a multidisciplinary team who comes together to come up with a strategy to help treat our patients. We can go into sort of the printers that we use a little bit later. I think it's neat to see how our whole team comes together. We're all using different types of additive manufacturing for different reasons. One of our clinics, the Bone Conduction Clinic, uses similar to dental implants to attach hearing devices for people with hearing issues. Most recently, our team has started printing surgical guides so that the surgeons and clinicians can place those implants in the exact location and have hopefully better success for our patients. Another aspect of IRSM is our speech language pathology team, and they use speech, voice, and swallowing to help rehabilitate our patients. The facial reconstruction program, primarily the facial prosthetics, they are a great team and they're using all sorts of additive manufacturing for printing molds to actually make the facial prostheses, as well as printing to print the surgical guides for reconstructive implant placement. Our big workhorse is the jaw reconstruction and rehabilitation program, and that's where I fit into the machine that is IRSM. And we help rehabilitate head and neck and trauma patients. We use all sorts of different scanning technologies to actually acquire all of our data, and then additive and as well as subtractive manufacturing to fabricate the prostheses for our patients. The surgical design and simulation team are the group of people who use CAD programs to design and simulate all of our surgical procedures. And then they use different printing technologies to actually produce custom-made surgical toolkits for our surgeons and for our patients.
Very cool. Thank you so much for sharing about that. And being a woman in a predominantly male field, did you face any challenges as you started getting into additive manufacturing?
I think when I entered industry back in 2007, it was a little bit different. Just the general dental field was predominantly male. I think I had some mayhaps negative experiences early on, being young, being fresh out of school, being female. But since then, it's been wonderful. Especially my team at IRSM is very supportive. We're champions for each other. So I'm glad to see that the world is changing, so that it's not the same type of experiences from before.
Mm-hmm. And what led you to kind of explore implants for cancer patients?
Dental implants are common. They've been around for a long, long time. Dr. P.I. Branemark is the father of the modern dental implantology. So I was pretty exposed to implants in private practice in the dental world, and jaw reconstruction and rehabilitation sort of takes it that next step further, where it's not just rehabilitating individual teeth or bridges, it's entire jaws and all of the function that sort of goes into that. So it's almost like the next level of conventional dental treatment, and then jaw reconstruction and rehabilitation.
Mm-hmm. And today, additive manufacturing can promise so much for patients going through some of like the hardest health challenges. So, what is your key message to someone exploring the medical side of additive manufacturing?
Additive manufacturing is a really broad term, and I really love this graphic from 3D Hubs, and it sort of breaks up all the different technologies so that you can see, sort of make sense of what's out there. The big thing when you're looking at dental or medical applications is, what are you trying to do? And sometimes the material will dictate your additive manufacturing technology more so than what the technology can offer. So it's sort of your end result. In the medical dental world, there's so many layers to what's required of something that's being produced. Can it be sterilized? Is it biocompatible? What are the long-term uses of the material? Can it be in an oral environment for a long time? Can it be implanted under the flesh for a long time? So it really depends on what your end goal is. At IRSM, we use pretty much 3 different kinds of technology. We have SLA, FDM, and PolyJet printers, which offer us a wide variety of options when we're working with patients. So here's a sampling of our equipment. So our Dimension, our Fortis, our Objet, and our Formlabs. Everything has a different function and similar technologies, but also different outcomes. So our Dimension, we use the ABS material, and the support is soluble. So it's really wonderful for printing full skulls that have those fine bones that are part of the anatomy that are important for our surgeons to keep and have a full skull. We use the Fortis and the PC ISO material for our surgical toolkits that our surgical designers design. This material we have gotten validated for sterilization, so it's safe to bring into the operating theater and use on actual patient. We have our Objet, we have 2 of them, and that's our PolyJet technology. We use it for prototyping, high accuracy models. If we want to do some sort of suck down or trial different things, that's our go-to. And our new baby is the Form 2 printer. And what's really wonderful about it is the plethora of dental materials that come with it that have all of those approvals that we were talking about for being in the oral environment, and high accuracy for fine definition models and things like that.
Nice. And how do you think that students today can learn and grow in the field of additive manufacturing? And do you know of any specific courses or offerings in the industry that can help them?
Yeah, we have, I mean, being involved and even watching some of these webinar series that you guys put on are just wonderful for exposure to what is possible and what is out there. So, you know, Instagram, YouTube, all of those type things, there's tons of stuff that's out there. As printers, you know, change from being that big refrigerator to something more desktop, that's a way to get involved for sure. One thing that I really like to emphasize is how cool printing technology is, but also it's the what are you gonna print? And that's to me is the really fun part. So this is sort of a brief thing of what our workflow might look like, from getting the requisition for please fabricate us a prosthesis or something, and then our data acquisition, whether it's an intraoral scan or a laboratory bench scan, to the design and the actual use. And for me, really, it's the design that is the interesting part of additive manufacturing, because the, you know, a printer is really neat and it's cool and it, you know, pulls something out of a vat of resin, which is really awesome, but it's the design and all of the thought process that really goes into the whole process of preparing the case and sitting down with all the different members of the team and coming up with what is it that we're going to create, designing, redesigning, verifying, then the cool 3D printing. One thing that's often forgot about in printing is the post-processing. Nothing really comes off the platform ready to roll. There's support material that has to be dealt with, cleaning, verify the models that they're actually what you have designed on the screen is what you're seeing on the screen, what's in your hand, and then the critical disinfection and sterilization step before it's actually used. What we use is a whole suite of different CAD programs to actually get what it is we're going to print. We use a lot of the Materialize programs, Magix and Mimics, so that's where we're actually taking the CT data from the patient scan and getting a skull model that we can work with. And then Magix is really great for constructing things around it. Our other big workhorse is Freeform, and it allows us to actually go in and sculpt. It has this really awesome haptic feedback device that you can actually feel what you're doing and feel the difference in the material and drag it across the screen. So it gives us a really good opportunity to take what we're given from an optical scan and change it into something that's really usable. Yeah, you talked a little bit before about being a girl in a cool technology thing, and I came across this on LinkedIn the other day, and dental technology is actually one of those jobs recently where hiring has flipped female. So we're starting to take over, and all of those old boys club days are sort of over and the girls are taking over, which is really, really exciting.
That's great. So that concludes our conversation with Carolyn today, and thank you so much for being here.
Thanks for having me.
For more information about Women in 3D Printing, please visit our website or LinkedIn page to learn more. And we hope to bring you more videos and talks about 3D printing in the weeks to come. Thank you so much again.
Thanks.